Welcome to Vision Plus and welcome back to this S.4 Mathematics. Today, we want to look at application of differentiation to kinematics. In other words, we want to see precisely how we can calculate velocity and acceleration using the knowledge of differentiation. Now from here, let me define the key terms. One, we have seen here we have velocity. So what is velocity? Velocity is rate of change of displacement. Okay, displacement we call it S in this case. Velocity is the rate of change of displacement. Remember, when we're saying rate of change, we are saying with respect to time. This is a measurement done relative to time. Therefore, we are saying that velocity is the rate of change. Remember when we defined differentiation, okay, we said it is the instantaneous rate of change, okay, of a function with respect to one of its variable. Now, the variable here with respect to one of its variables. Now, the variable here is time when we are looking at the displacement. So, velocity is the rate of change of displacement. This means that it is how fast the displacement changes with change in time. So we shall say it is change, okay? Velocity is change in displacement relative to time or change in time, okay? Rate of change of displacement with time. This means that velocity is ds dt, okay? This is the expression for the velocity at any time, okay? So velocity is the rate of change of displacement. So v is ds dt. This is what we must keep in our minds, okay? Now, let us say that we have a body which has a velocity of 0. So what does it mean if the velocity is 0? If the velocity is 0, if the velocity of the body is 0 meters per square second, what does it mean? It means that the body is at rest. The body is at rest, or simply the body is not moving, or it is not in motion. So if the velocity is a speed, okay, it is a speed, or in other words, the speed is the magnitude of velocity. But the good thing with velocity is that it tells us the direction. Now, if the velocity is 0, if the speed of a body is 0, it means the body is not moving, it is at rest. Okay, that is what you must know. Now, what is the key takeaway from velocity? The key takeaway from velocity is that velocity at any time t is given by the expression s dt. That is the rate of change of displacement with time. And what is the unit of velocity? V. The unit is meters per square second. Okay? Why? Because displacement S is measured in standard unit of meters. M. And then time, say T, is measured in seconds, which is S, similar to S. So this is what is very important for us to know. This is one. Two is that if the velocity is 0 meters per second, the body is not moving. So the body or the object is at rest. In other words, it is not moving. These are the two things that we must take away from the concept of velocity. Now let's go to acceleration. What is acceleration in your physics? Acceleration in physics and in any other subject where it is applicable is that we are saying acceleration is also rate of change. Rate of change of velocity v. Okay, acceleration is the rate of change of velocity v. What does it mean? It means that we are measuring, okay, we are measuring the change in speed, okay, relative to the change in time. Remember, when we say rate, then we are meaning time. So we are saying how fast is the speed or the velocity changing with respect to time. Okay, that is what we are saying. So acceleration A is given by the change in speed or velocity. Velocity. It is strictly the change in velocity relative to the change in time. The change in time. That means acceleration is the rate of change of velocity. When we say rate, we have included the aspect of time. But in some books, we find that they are saying acceleration is the rate of change of velocity with time. It is okay. Even velocity is the rate of change of displacement with time. No problem. But after saying rate, you have included the aspect of time. Now, what does it mean here? How do we get the change in velocity? Now we know that initial velocity u, okay, and then we know that the final velocity is denoted with v. Now we are saying the change in speed. That means acceleration is what is the change in speed or the change in velocity. The correct term here is velocity. Okay, so what is the change in velocity? It is the final velocity minus the initial velocity divided by the change in time. Okay, which is the final time minus the initial time. But here, the questions that we shall handle, they will just give us the change in time. Okay, just for this stage, they will always give us the change in time. Now, this implies that acceleration is v minus u out of t, where t stands for, where t is standing for change in time. Change in time, that is the final time minus the initial time. That is what we must know. This is acceleration. Now, what are the units of acceleration? Now, we know that here the numerator is speed, which is in meters per second. And again, we are dividing by time, whose units are also seconds. So, dividing meters per second by second gives us meters per squared second. Therefore, acceleration is measured in meters per squared second. That is the unit of acceleration. Now, I need to give you one more concept again. Our time is going. Now, if the acceleration is 0, what does it mean? If the acceleration if the acceleration is 0 meters per square second. What does it mean? It means that there is no change in velocity. Okay? It means there is no change in velocity. In other words, that body is moving with a constant velocity. It means that the body moves with a constant velocity. Okay? That is, it means the body moves with a constant velocity. Okay? In other words, we are saying the final velocity is the same as the initial velocity. The final velocity v is the same as the initial velocity u. Say that if v equals to u, it means our acceleration becomes v minus u. But still, u is the same as v. So the final speed is the same as the initial speed. That is v minus v out of that time. That means we shall have 0 out of time. It doesn't matter how long the particle has moved. For how long the particle has moved, the acceleration will be 0. Okay? It means that the speed of the body is not changing. It's acceleration per square second. It means that the speed is not changing, or the velocity is constant. What are the two key takeaways from this concept? One, you must know that acceleration at any time t is given by the change in velocity over the change in time. So acceleration at any time t is dv dt. Okay, it is dv dt. That is what you must know. What do you need to know again? You need to know, I'm following this, that if the acceleration is 0 meters per square second, the body moves with a constant or with a uniform or constant velocity. I remember when I was teaching in Giva, I asked the class, what does it mean when the acceleration is 0? The students say it means that the body is at rest. I said no. The body is only at rest when the velocity is 0. But when the acceleration is 0, it means the body is moving with a uniform velocity. It is moving with a constant speed. So that is what you must take away. You must also keep the units in your mind. That acceleration has units of meters per square second. And which one again? Time. Because time occurs here, time is always in second. These are the units of the measurement that we shall use in this case. What is the summary of the whole thing that we have discussed? The summary is that you must know that velocity is the rate of change of displacement. Therefore, in this concept, we are saying that the velocity at any time t is given by ds dt. Take it away. Number 2, you must know that if the velocity is 0, it means the body is at rest. It is not moving. Well, you must know the definition of acceleration. It is important. It is the rate of change of velocity with time. Then you must know the expression that the acceleration at any time t is given by dv dt. You must keep that in your head. Also, you must take away that if the acceleration is 0, it does not mean that the body is at rest or not moving. It simply means that the body is moving with a constant speed, with the same velocity. This is what you must take away. And as well, you must keep in mind all the units. We have taken a lot of time explaining this. Why? Because it will be really very important when we are looking at numbers. That is the calculation of velocity and acceleration. Thank you for making it this far following the video. Stay blessed.